context around experimentation literature. There are three areas of experiments. One, single and multifactorial experiments in the traditional statistical literature. So this is a traditional, we test on plants, we test on patients, and there we have single and multifactorial, whether we change one parameter or multiple parameters. Two, running web experiments. So Kochavi has done a paper on this area in a relatively comprehensive way. He has both a book and also papers on web experiments. Three, interleaved experiments. This is the specific type of experiment focused on evaluating ranking changes. Interleaved means that we run like the test sequentially, 10 minutes this use case and 10 minutes this use case. What is better? If I give you Coca-Cola and Pepsi Cola to drink and taste and compare them as a single user, then you would be able to give me a better choice than if I split the population to half, give half of them Coca-Cola and half of them Pepsi Cola. Right? Because you will feel how they both taste. The same with interleaved experiments. If you type a search query and you get results, and later on you type and you get different results, and you prefer the different results because you're looking for a dishwasher, and in the experiment that I gave you 10 minutes later, you got a much better dishwasher, then this is interleaved experiments, meaning we don't just split things to half, but we interleave the UX that you get. Okay. Structure and key concept that support this proposed experimentation system. Domain, this is the segmentation of the traffic. I think here this means that we have multiple domains. If we have YouTube, we have the search for videos, we have the recommendation of the videos, we have the video play itself. So each of them is a different traffic. Two, layer. This was domain, layer. This is a subset of the system parameters. As we said, dependent variables are in the same layer. You cannot change them in parallel. Experiment. This is the segmentation of the traffic where 0 or more system parameters can be given alternate values. Yeah, so we change the parameter of this is experiment. We change the parameter of the system. And change how the incoming request is processed. Yeah. For launch layers. They are different from experiment layers in that they are contained within default domain. They are separate partitioning of the parameters. So we have separate partitioning of the parameters. Let's see. They are used to gradually roll out changes to all users without interfering with existing experiments and to keep track of these rollouts in standardized ways. Yeah, so launch layers appears how we roll out things, how we launch the layers, how we gradually bring layers to the users. 5, diversion types. How domain is diverted. This can be done either randomly or through using cookie mods to generate traffic diversions. So when traffic comes to a domain, how we divert it. The mechanism for the diversion of the traffic into the experiments. 6, canary, new code. These are methods used to test new code on a small amount of traffic and make sure that the new code isn't buggy. The code would work when there is more traffic. Binary is a collection of code scripts with functionalities, like services. In this context, it's some type of an executable. Given the infrastructure, what was the title of this? Structures and key concepts that support this. Okay, so these are the key concepts, the fundamentals that support this experimentation system. Given the infrastructure, the process of evaluating and launching a typical feature follows the following. 1, implement new feature in the right binary. Code review, binary push, default values. We implement the feature. 2, create a canary experiment with small traffic to ensure that the feature is working. If not working, then more code needs to be written, revised. 3, create experiment or set of experiments to evaluate the feature. Experimentation component includes specification of diversion type, parameters, conditions, and affected system parameters. 4. Evaluate the metrics from experiment depending on the results. Additional iterations may occur. Additional iterations occur by modifying, creating new experiments. 5. If feature in question is launchable, then launch process is initiated. What is the launch process? 6. Launch layer. And launch experiment is then created. This is to gradually ramp up the launch layer experiment and then finally delete the launch layer and change the default values of the relevant parameters. Okay, it's great in the description, it's still abstract. We still don't see the very exact process. Tools and processes to support overlapping infrastructure. Okay, so now they will focus on the overlapping infrastructure. Tools, data file check utilities. Automated data checks on input files. We have here input files. This could hint us that they use configuration in files. So tools, data file checks utilities, automated data checks on input files to prevent useless broken experiments. So they have some kind of process of validation on the experiments from taking place. Checks include the following: 1. Consistency and constraint errors. 1. Uniqueness of IDs. 2. Whether, I guess they mean here experiment IDs. 2. Whether experiment is in the right layer. 3. Whether layer has, when would an experiment be in the wrong layer? If it's changing a variable which it's not independent of in a different layer. 3. Whether layer has enough traffic to support. 4. Is the experiment asking for the traffic claimed by other experiments? 5. Basic experiment design checks. Does experiment have control? 6. Is the domain diverted in the same way as others? Tooling. Real-time monitoring and experiment analysis. These are tools that capture and track basic metrics as quickly as possible in order to determine if there is anything unexpected happening. This actually goes beyond the overlapping experiments. It looks like the basic functionality was separating the experiments into layers. And now we're trying to solve a different problem. Once we have so many experiments, then we need to provide some automatic checks, even if we didn't have the multi-layer approach, right? Tools utilities include: 1. Choose metrics to track. 2. Setting expected range for individual metrics and gradual guardrail on these metrics. 3. Guardrail communication, how and where communications are delivered. Experiments shutdown. 5. Configuring and adjusting experiment parameters. While the above is used to enable simultaneous experiments and expanding the experiment process, experiment analysis tools is the other side of the coin. The experiment analysis tools, so we have the runtime of the experiment is running, users are getting the CX, and then on the other hand, we have analysis of experiments. The experiment analysis tool is used to provide accurate values for the suite of metrics that experimenters examine to evaluate the experiment. Multiple metrics can be combined into a single objective function, but the experiments can also examine a suite of metrics. Key design goals of an experiment analysis tool include: 1. Correctly computed and displayed confidence intervals. 2. Good UI for ease of use and understanding. 3. Support for slicing. Aggregate numbers should be drilled down. So they support drill down. 4. Extensibility. Custom metrics should be added. Could be added. Should be added. Experiment design, sizing, pre-post periods. Experiment size of an effective size of an experiment, N, is 1 divided by control query plus 1 divided by experiment query, control, and then we do 1 over them. Let's see, in this iteration, the estimates of a standard error can be a challenge. Pre-period is a period of time prior to starting an experiment where the same traffic is diverted into the experiment, but with no changes made. This is to ensure the traffic diverted is really similar to the control. This is like an AA experiment. Okay, makes sense and looks good. I really like this style of safety. We first divert the traffic. Let's say first, without applying any changes on the CX, that we get the traffic that we expect. Otherwise, we could think, wait, are we not getting the traffic that we expect because of the actual CX change? This is a good safety AA test. Post period is the same, but after the conclusion of the experiment, this is useful for determining if there are any learned effects from running experiments. Experiment, infrastructure, adoption, education. Tools and infrastructure discussed above are technical considerations required for enabling more, better, faster experimentation. On the people's side, experiments should be one, well designed, two, results of an experiment are understood and disseminated. Experiment council. This is a council of engineers that review lightweight checklists that experimenters fill out prior to running experiments. So prior to running experiments, you need to go to a checklist. These questions address basic experiment characterization. What does experiment test? What is the hypothesis? 2. Experiment setup. Which experiment parameters are varied? What each experiment offsets tests. 3. Experiment diversion and triggering. What diversion type and which conditions to use for diversion. What proportion of diverted traffic triggers the experiment. Experiment analysis. Which metrics are of interest. How big of a change the experimenter should like to detect. 5. Experiment sizing and duration. Given the affected size, the experiment has sufficient statistical power to detect. We have enough statistical power. 6. Experiment design, whether pre and post period is warranted. The benefit of this is that it is useful way for disseminating updated best practices with regards to experimentation. Checklist is a hosted web application. Interpreting the data. The other process put in place is a forum where experimenters bring the results to discuss with experts. The goal of this forum is to 1. Ensure that the experiment results are valid. 2. Given valid results, make sure that the metrics being looked are complete with regards to understand what's happening. 3. Given a full set of results, discuss and agree on whether overall the experiment is a positive or negative user experience so that decision makers can use the data to determine. Okay, this is the end of this post. We would need to look at the actual paper because they didn't really describe how the multi-layer actually works. How do you determine which parameters exist in each layer? How exactly? Maybe the paper also does not discuss this. So this was how Google conducts more, better, and faster experiments with this nice image.